Here in section 8.6, we're actually not covering anything brand new. We called this section Proofs Practice. Proofs are tricky enough that we wanted to give one extra day of watching them be done so that you could get some of that extra practice. So homework tonight, you're going to be practicing all different kinds of proofs that we learned about so far. They're just mixed up with one another. Determine if the triangles are congruent. If they are, finish the congruency statement and tell which congruence postulate you used. If you cannot tell, say why. So these two sides are congruent, these two sides are congruent, and these two sides are congruent. And so triangle A, B, C would be congruent to triangle D, B, E. Remember, the order here matters depending on the order here by side, side, side. So that's one of the reasons that we talked about. If you look at B, let's see. These two sides are congruent to each other. These two sides are congruent to each other. These two angles are congruent to each other, but notice that they're not labeled as being right angles. And so for this one, there is no ASS or SSA. These are not reasons that you can use to prove that triangles are congruent to each other. And so for this one, there's not enough information to decide if they're congruent. Question number 2 says to mark the picture with the given information and add marks for vertical angles or reflexive property if needed, and then complete the congruent statement. Triangle ABC is isosceles with the vertex at B, so that means that these two sides would be congruent to each other. Side BD is perpendicular, don't forget that's what that symbol means right here, to side AC, so that means that both of these would be right angles. And let's see, side BD would be congruent to itself right here. That's because of the reflexive property. I'm going to add on to my notes that this means perpendicular, just so that you remember, and perpendicular means 90 degrees, just so you remember. And so for this one, triangle ABD would be congruent to triangle CBD, and the reason that they would be congruent is because of HL. Because the hypotenuse in this triangle is congruent to the hypotenuse in this triangle, the side of this triangle is congruent to the side of this triangle, and they're both right triangles. On example 2b, we're given that side SE is congruent to side SU, and we're given that angle M is congruent to angle O, and that's all they tell us, but notice that these two intersect to form an X. That means that this angle right here, angle ESM and angle USO, these two angles are congruent to each other. And the reason why they're congruent to each other is not because it's given to us, it's because they're vertical angles, and we know that vertical angles are always congruent to each other. So for this one, triangle MES is going to be congruent to triangle OUS, and the reason why they're congruent is because of angle, angle, side. These two angles are the same, these two angles are the same, and then the side that's not between the two angles is congruent to the side that's not between or included between the two angles. And so the reason for this one would be angle, angle, side. Whenever you start a proof, it's important to look at the picture. There are 5 triangles over here. There's this little one, this little one, and this little one. But then there's this big one where it overlaps, sort of like these two together. And then there's this big one over here where it overlaps. And so I always like to start by looking at what I'm trying to prove. So triangle ABE, so the big triangle on the left, is congruent to triangle EDA, so that's the big triangle on the right. I'm given that side AB is congruent to side DE. Notice that I'm being careful about always marking that in the picture. I'm given that side BE is congruent to side AD. That's kind of hard to mark in the picture, so most of the time I'll just make the markings kind of close to this center-ish point right here, but maybe not right on top of it. Anyways, this whole side is congruent to this whole side. Side AE is on both the triangles, and AE is congruent to itself because of the reflexive property. And so on this one, I'm trying to prove that the two triangles are congruent to each other. So I'll say that triangle ABE and triangle EDA are congruent because of side, side, side. Notice that for this one, I'm not going to use CPCTC, that thing I learned about yesterday, because you're trying to prove that the triangles are congruent to each other, not that a part of one triangle is congruent to a part of another. We'll need to use CPCTC possibly in other proofs when we're trying to prove that parts of the triangles are congruent to each other, but we don't need to use it in this one because we are finished with SSS. Alright, so here we go. We're going to practice 3 more proofs. In these videos, I always recommend that you consider stopping the video so that you can look ahead in the proof, try to see what you would be able to fill in on your own. It's kind of like extra practice. I'll mark my two givens. AB is parallel to DE, and that means that angle A is congruent to angle E. Oh, I forgot to mark on the picture that they were parallel. Let's add that in too. If these two lines are parallel, you'll remember from last unit that the alternate interior angles are the ones that make a Z with each other. If you extended the lines on your paper, these two parallel lines could keep going on, and then this segment here, AE, would be the transversal that cut between them. Alternate interior angles are always going to be congruent to each other. So over here, for the reason for this one, you can write out alternate interior angles, and then I just want you to put in parentheses AIA. Sometimes you'll see it abbreviated like that, and I don't want you to see the abbreviation and not know what it means. Angle ACB is congruent to angle ECD. Now this one has nothing to do with the two lines being parallel. The reason why these two angles are congruent to each other is because they're vertical angles, and we've said before that vertical angles are always congruent to each other. Side AB is congruent to side DE. That was a given. That was the second given up here. And so we're finished. These two angles are congruent, these two angles are congruent, and the side that's not between them is congruent to a side that's not between them. So this would be angle, angle, side, not angle, side, angle. On number 5, you start by being given that the two sides are perpendicular to each other. Here, I'm just going to go find the other givens so that we don't get confused later. There's just those two. Okay. So BD is perpendicular to AC, and that means that angle ADB and angle CDB are right angles. So the reason why those two angles are right angles is because that's the definition of perpendicular. That's what perpendicular means. And then angle ADB is congruent to angle CDB. That's because all right angles are congruent. The right angle congruence theorem says that all right angles are 90 degrees, which means that they're all congruent to each other. If segment BD is the angle bisector of angle ABC, that would mean that this half of the angle, angle ABD, is congruent to this half of the angle, angle CBD. And that's because of definition of, definition of bisector. You could write definition of angle bisector, you could write definition of bisect or bisect, any of those would be fine. Side BD is congruent to itself because of the reflexive property of congruence. And for this proof we're done, because triangle ABD would be congruent to triangle CBD, because these two angles are the same, these two angles are the same, and the side in between them is the same as the side in between them. So be careful, this one's angle, side, angle, not angle, angle, side. Just because they're right angles doesn't mean that you're going to use HL. You don't know that the hypotenuse of this triangle is equal to the hypotenuse of this triangle, so you can't use that as one of your reasons. Or you can't use HL rather as your concluding reason for why the two triangles are congruent to each other. If you were going to use HL, you would have to know this information, and you would have had to have set up here that the two triangles were both right triangles. And on question number 6, you're given that C is the midpoint of both AD and BE. So this is one, well, it's actually two things that are given, but it's all wrapped up into one. So if C is the midpoint of AD, that would mean that this piece was congruent to this piece. And if C was the midpoint of B, let's see. If C was the midpoint of, oh, I guess I labeled it backwards. If C was the midpoint of AD, no, AC would be congruent to CD, so that would be this one right here. And then if C was the midpoint of BE, that would mean that this piece was congruent to this piece. And so both of these reasons are the same. It's definition of midpoint, and then again definition of midpoint. So on both of these, it has the same reason for the sides being congruent to each other. The reason why angle BCA is congruent to angle ECD has nothing to do with midpoint. It's because those two are vertical angles, and vertical angles are always congruent to each other. And we're finished, because we're trying to prove on this one that triangle ABC is congruent to triangle DEC. So the little triangle over here is congruent to the little triangle over here. And we have all we need to prove that those two triangles are congruent to each other. These sides are congruent, these sides are congruent, and the angles in between them are congruent. So our reason for this one is going to be side angle side.